All right, so we are going to be going into the Pythagorean theorem this week. And before we jump right into the Pythagorean theorem, which we'll talk about more tomorrow, we're going to kind of take a little sidestep and we're going to learn how to simplify radicals. And the reason for that is because when you use the Pythagorean theorem, you end up with a radical as an answer, and you always want to write your answers in the simplest form. And so we're going to learn today how to simplify radicals so that tomorrow, when we start using the Pythagorean theorem, we will be able to simplify our answers. Okay? All right, so first of all, I want to talk about what a radical sign is, okay? And we kind of get lazy, and we call it a square root sign a lot of times because 99% of the time it is a square root, and I'll show you how to tell the difference. So with example number 1 here, in math, there are always numbers that are there, but they're not there. We've talked about them a lot. Every whole number has a 1 underneath it. Every number has a 1 as an exponent, right? So if it's not there, it's there. Well, with radicals, if it's not there, it's there. There is actually a number that is here that's never written, and that number is a 2 right here on the outside. Whoa, that's really thick. Let's thin that out a little bit. There is actually a 2 in that outside V. Can you put your Chromebook away? Like, close it up and put it away, please. Thanks. There is a number that's there. There's always a number in that outside V. It's called the root. And what it tells you is that whatever number is trapped underneath that radical, it can only escape if there's 2 of them. Okay? So a very common, and you can make this actually you can make this number just an example off to the side or whatever, because I want to just kind of talk about this. If I were to say, what's the square root of 36, without even have to think about it or do any math, what would the answer be? Say it. 6. The square root of 36 is 6. Why is that? Well, the math reason behind it is because 36 is actually 6 times 6. And because it's trapped under this root, this square root sign, or this radical, I get in the habit of calling it a square root sign. Because 36 is trapped under a radical, the only thing that can come out is if you can circle something as a pair, then the pair comes out as 1. And the reason for that is because 6 squared, or 6 times 6, is 36. Okay? So when something is trapped under a radical sign, you can only break it loose or free it if there are the right number of them grouped together. Think about poker. You've got 2 of a kind, 3 of a kind, 4 of a kind. So, and you don't have to even put this one in your notes. I just want you to kind of be running down the right line that I'm thinking here. What if I was to give you a square root symbol, but put a 3 out here? And I did it. I said a square root symbol. It's a radical. And this is why we shouldn't get lazy and call it a square root symbol. This is a cube root because there's a 3 outside. So if there's nothing written, you just know that it's a 2. If it's something other than a 2, it will have to be written there to tell you what it is. And all that means is that in order for a number to be freed from under the radical, think of radical as a jail. The only way for a number to be freed from this jail is if there's 3 of a kind. So you have to factor 8, and that's what we're going to learn about doing today. But you have to factor 8 down into all of its prime factors. So you could go 2 times 4 is 8, and then 2 times 2 is 4. Well, now I'm down to all prime factors, and can I circle 3 of a kind? I have 3 2's, so the cube root of 8 is 2. Okay, and I'm kind of jumping ahead of myself, but I just want you to see that it's not always going to be a 2 out on that V. Now, for what we do pretty much in Algebra Lab, we're pretty much just going to deal with square roots. We're probably, unless we just do it on a day where we don't really have a whole lot to do and we just kind of want to play with it, we're probably not going to deal a whole lot with cube roots and 4th roots and 5th roots and 6th roots, but you can put any number out there you want. And it just means that you have to have that many before you can circle them and pull them out as 1. Okay? So that kind of takes me to a term that I just used, and I said, well, I needed to factor a number in order to decide what I can circle and bring out. So What does that mean? Okay, so if you have a number underneath a radical, first thing you have to do, and if you're a steps person and you want to write down these steps, that's probably a good idea. Step 1 is to factor the number under the radical. Okay, factor the number under the radical. Well, factors means multiplying. So we are going to break this down, this big number down, into all of the prime numbers that all multiply together. And remember, we've talked about this, I think. Was it this class or the other class I talked about the Legos? Must have been my algebra class. Think about if I made a Lego car, right? And I put it all together with all the Lego pieces, all different colors and all of that. And then I gave it to you and I had you break it apart into little pieces. Do you still have all the pieces needed to build that Lego car? They're just broke apart in little pieces. That's what factoring is. We're going to break apart 192 into all its prime little pieces. And the way that you do that is called a factor tree. So you start out with you're going to branch 192 into two numbers that multiply together to give you 192. Now the rule of factoring, and this is really important, so you're going to want to put this over here. Always, and it's very important here, always use prime numbers on the left. And I'll show you what I mean. Okay, this is the one of the most important parts of it. So everybody make sure you have this little dot written down. Always use prime numbers on the left. So what does that mean? That means I'm going to break 192 down. And because it's even, what's the lowest prime number I can start with because this is even? A 2. So that means I want to know what number times 2 gives me 192. And the way you do it in your calculators, you just punch in 192 divided by 2 equals, and you get 96. So on the left side, I used a 2 because it's prime. On the right side, I get whatever is left when I divide it. Now I'm going to do that same thing again, only now I'm going to mess with 96. I'm not messing with 192 anymore. That's already been factored. Is 96 still even? So I'm going to stick with 2. I'm going to ride 2 out all the way until I can't anymore. So in my calculator, I'm going to hit divided by 2 again. And I'm going to get 48 because 2 times 48 gives me 96. Is 48 still even? Okay, so I'm going to keep going with my 2's until I can't use 2 anymore. 48 divided by 2 is 24. Notice on the left, I have 2, 2, and 2. I'm keeping my prime numbers on the left, and I'm keeping all my 2's together, and that'll come in handy here in a minute. Is 24 even? So I can stick with 2, right? 2 and 12. Is 12, whoops. I hate when it does that. There we go. I was trying to move it up. All right, is 12 even? So I'm going to stick with 2, and that's 2 and 6. And then 6 is even. I'm going to stick with 2, and that is 2 and 3. Now I'm going to stop here because all the 2's and that 1, 3 are all prime. And think about your prime numbers. 2, 3, 5, 7, 11, 13, 17. I think that's about as high as we'll get in here. Okay, those are your prime numbers. It means that they're not divisible by anything else other than 1 in themselves, and we don't worry about the 1. So we have 192. Think if 192 was a Lego all put together, we have it busted out into all the little bitty Lego pieces that make up 192. Now, because this right here is a what out at the V? It's a 2, right? That means we are going to circle pairs. Yes.
Can we with the 24, can we put 6 in here?
Okay, you can, but is 6 or 4 prime? And what's the biggest rule I said right there? Always what? Always use a prime number on the right. And I'll show you why, okay? Yes, you can, and you would eventually end up with all the same little pieces, but it gets so messy, and you have some high and some low and some 2's and some 3's and some numbers are all over the place, that when you get to this step right here, it makes it a lot harder. And I'll show you exactly what I'm talking about. All right, so step number 2 is to group together, and I'm just going to be lazy here and say pairs because we're only going to be dealing with square roots, so only pairs. So we're going to group together pairs, okay? When you group a pair together, they break free from the radical jail, meaning I'm going to circle this pair of 2's, and they are going to break out as 1, 2. Then I'm going to group together this pair of 2's, and they are going to break out as 1, 2. Then I'm going to group together this group of 2's, and they are going to break out as 1, 2. Now, what about the poor guy that doesn't have a pair? What do you think happens to him? Can he break loose from radical jail? Does he have a pair? Is there 2 of them? So that means that one is still trapped underneath. Cannot be broken loose because it doesn't have a pair. And I like to use the circles and squares. That to me visually helps keep me straight of what's coming out and what's staying in. Now, because I divided all of these down to their bare primes, the very last step, so step 3, is to remultiply if needed. So what does that mean? Well, I brought out 3 different 2's. So 2 times 2 times 2 is 8, radical 3. That is your simplest answer of what the square root of 92 equals simplified. So you factor the number under the radical, always using prime numbers on the left. You group together your pairs. And of course, if you need to put this in your notes, it's important. You group together your pairs, and pull out, right? They pull out. Because your pairs get pulled out. So, and I want to address Gabby's question because it was a really, really, really good question. And I want to show you why. So I'm going to take this same number, right? I'm going to take 192. And I'm going to break the rule of always having a prime number on the outside. And let's say that I play around with it and I can tell that 192 is divided by 12. I'm picking a random number, okay? So I can do 12 times, well, when I divide 192 by 12, I get 16. And don't put this in your notes, okay? This is why we don't do it this way. Well, then 12, I can see 12 is actually 4 and 3, right? And 16, I could do 2 and 8. And then 4 can still be factored to 2 and 2. 2, 3 can't be factored, but 8 could be factored to 4 and 2. And then 4 is factorable to 2 and 2. Now, would everybody agree that I got down eventually to all primes? All my numbers at the bottom, here, 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 and here, right? Those are all the base bottom ones. Count up what I had in the other one. How many 2's did I have on the other one? Total of 6. And then I had that 3, right? What do I have here? I've got 1, 2, 3, 4, 5, 6. I have 6 2's and I have a 3. You will get the same answer. But when you get to this part where you're supposed to circle pairs, well, there's a pair and they come out. And there's a pair and they come out. But see how it gets a little, it gets a lot harder to start thinking, okay, well, this would pair with this one. So they would come out. And then what if you lose your 3 and you forget about it because it's chucked up in here and you forget about it? So while you will still get the same answer, because multiples of a number, they're not going to change no matter what order you do them. You could have done this. You could have divided 192 by 4, and you could have gotten 4 and 48, and you could have done it that way. You could have done it 6 and whatever. You can do it a bazillion different ways, and you will always get the same number of prime factors at the bottom. It's just notice the difference of here trying to find your pairs and up here finding your pairs. Do you see the difference? Yeah. And by sticking with 2, once I started with 2, by sticking with 2 until I couldn't do 2 anymore, that means that when I go to circle 2's, they're all lumped together. So I could have, up at 48, I could have divided 48 by 3, and gotten, what, 48 divided by 3 is 16. And then I would have still gotten all the other 2s, but that would have stuck a random 3 up in the middle. And while it's the right ones, it makes them harder to circle. So that's why I say once you start with a 2, if you can't start with a 2 and you end up starting with a 3, ride the 3s all the way until you got to move to a different number. And then try 2s, then try 3s, then try 5s, 7s, and so on, okay? All right, so let's look at 98. We're going to do the exact same thing here. Okay, we're going to factor 98. So the first thing we're going to do is, whoops, I'm going to go back to black here. It's even, so what should I start with? 2. So in my calculator, I'm going to hit 98 divided by 2, and I get 49. Okay? Now, 49 is not even, so I know I'm done with my 2s. I have factored out all the 2s that are in there. You can try to divide 49 by 3, but you get a decimal. 49 is not divisible by 3. It doesn't end in a 5 or a 0, so we know it's not divisible by 5. When you divide 49 by 7, you get 7 times 7. 2, 7, and 7 are prime. I'm done. I'm done with the factoring part. Now, all I need to do is circle pairs and pull them out. I have a pair of 7s. They come out as 1. They always come out as 1. And then what doesn't have a pair? My 2, so it stays trapped underneath, and that is the reduced version of 96. Having your calculator nearby and using it is a lifesaver. When I get a big number, if it's even, I don't even think about what to do. I click the big number, divided by 2, hit equals, then hit divided by 2, hit equals, hit divided by 2. You don't even have to clear it and retype in the big number every time. You just keep going, divided by 2, divided by 2, divided by 2, until you realize you don't have an even number anymore. Then check 3, check 4. Does anybody know how to check and see if a number is divisible by 3? Anybody? If you add up 2 plus 1, that's 3. Add up 6. 3 plus 6 is 9. Is 9 divisible by 3? Then my big number is. Now this one's even, so I'm going to start with 2. But if you ever want to check if something's divisible by 3, just add up the digits, and if that number's divisible by 3, then the whole number is. Just kind of like, So I can give you a number, like I can give you this number. One, 5, 6, 7, 8, 14, 15, 16. Okay, if I give you that number, 1,436,000, is it divisible by 3? You should be able to tell me in about 30 seconds. One plus 4 is 5, plus 3 is 8. Yeah. Yep. Plus 3 is 8, plus 6 is 14, plus 2 is 16, plus 8 is 24. They all add up to 24. If you're not sure about 24, what's 2 plus 4? 6. Is 6 divisible by 3? Then 1,436,280 is divisible by 3. I know. I learned that in my first year teaching here. One of my students taught me that. I thought that is the coolest thing I've ever seen. So anyway. All right. So we have a big number here. No big deal. It's super easy to do. Is it even? Yeah. So we're going to take in our calculator. 216 divided by 2 equals, and we should get 108. Still even, so I'm going to ride that 2 all the way until I can't anymore. Divided by 2 equals 54. Still even, I'm going to divide it by 54 by 2 again. I get 27. All right, it's 27 even. That tells me I'm going to stop with my 2s, and now I look at 3s. Is 27 divisible by 3? Yeah, 2 plus 7 is 9. 9's divisible by 3. So then I'm going to punch my calculator, and I'm going to hit divided by 3. So 3, when I divide 27 by 3, I get 9. Is 9 prime? Can I stop? What do I got to keep doing? I got to keep going because 9 isn't prime. If you stop too soon, with a number that is still divisible by another number, you're not going to get the right answer because you won't have the right pairs. You should end up with nothing but 2s, 3s, 5s, 7s, 11s. That's it. Okay? All right. So down to my next step. I circle a pair of 2s. They come out as 1. I circle this pair of 3s. They come out as 1. What couldn't I circle? This 2 and this 3. Neither one of them had a pair. The 2 didn't have another pair. There was an odd number. And the 3, there was an odd number. And then the last step is remultiply if needed. So 2 times 3 is 6. And then under the radical, 2 times 3 is 6. So that is 216 simplified right here. Ah. Huh? Nope, it's not hard at all.
It's actually like
Yep. Now, this one, I'm going to show you 2 ways to do it. One is if you right off the bat, you recognize 36 is perfect. What is the square root of 36? 6. Work done. I'm fine with that. If you recognize it as a perfect square and you just want to do this, that's fine. What if you don't recognize it as a perfect square? Let's just say your brain freezes and you don't realize that 36 is perfect. Well, it's even. It's even, right? So 36 divided by 2 is 18. 18 divided by 2 is 9. I'm done with my evens, but 9 I can divide out as 3 and 3, right? Now, I circle a pair of 2s. They come out. I circle a pair of 3s. They come out. What do I have still trapped underneath that cannot come out? Nothing. This is what's known as perfect because everything breaks free, the radical disappears, and 36 is a perfect square. So if you recognize it right off the bat, you can go right to the answer. If you don't and you factor it and you circle everything and have nothing left, then there is no radical left because there's nothing left trapped underneath it. So you don't need a radical in the answer. Make sense? You don't even have to put this one in your notes. I just want to show you you're not always going to have something even, and that's okay, right? 63 is not even. I have to skip the 2 one. But is it divisible by 3? And I would get 21. Is 21 divisible by 3?
oh yeah.
Okay, now I'm to the circling part. I have a pair of 3s. They come out as 1. What about my 7? Trapped underneath, and that's my answer. So if 2 doesn't work, try 3. All right? If 3 doesn't work, try 5. If 5 doesn't work, try 7. It's always your prime numbers. And if you need it, here's in your notes. You can put this in your notes. Prime numbers. Okay? If you're not familiar with them, I would jot these down. They are 2, 3, 5, 7, 11, 13, 17. I think that's not all of them, but I think that's as high as you guys need. Which means you're always going to start with one of these on the left, and you're going to keep going until you get to where your bottom ones are all prime. So you can't end on a 9, a 12, a 10, a 6. Okay, you have to end with all primes, and you have to start with primes. Start with prime and end with prime. All right? Okay. Just see if you can't work through just a couple of these before the bell rings. You do not have to finish this, and it is not homework, okay?
This is why I failed math. I thought primes were on.
Ah, gotcha. For those of you at home, go ahead and click load on the button at the bottom, and that will load your assignment in Kami. Make sure you show your work, including the factor tree for every problem. Okay? Let me know if you have any questions.